All right. So what I'm presenting here is what theme number one focused on. It was about Ottawa Smart City Strategy 2.0, and we'll dive right into this. So I want to really thank my team. We are named the Busy Beavers. So just a bit of recall what the theme one was all about. It was to see or study if there's any kind of relationship between the spectrum intelligence communication and the travel behavior. So Monica explained to us that there might be some kind of relationship between these two, and in this hackathon we relied on the data to show us if there is anything. And this is what we're going to show you today. So our data hackathon starts with a question, and I'm taking Monica's question here. Can we develop a big data analytical workflow to predict the relationship between travel behavior and the spectrum usage? And I'm skipping the rest of the question. And so what we had also is a few ideas, like scenarios. So what do we expect from you guys, Busy Beavers? So the scenarios were substitution, which is communications leading to a decrease in travel demand, complementarity, which travel demand leading to an increase in communications, or modification, which change of existing travel pattern by the use of communications, or is it neutrality, so no impact on one medium or the other. So we tried to study which kind of relationship there was. So the data we started off with, we used the publicly accessible OC Transpo data, such as bus routes, bus stops, and our bus schedule. And we also looked at OpenSignal, the Wi-Fi speed test, and the LTE speed test done over the mobile network. As tools, we used QGIS, the FME Workbench, and just for the purpose of this slide, Google Earth. So we focused on one particular area, which is Ottawa. I think it's large enough. It's bigger than some countries. So this is our base map that you're seeing, so basically Ottawa-Gatineau area. And overlaid now on top of it is the heat map of the OC Transpo bus routes. And and the different colors of the different lines are the actual OC Transpo routes. Why is this important for us to see this kind of information? It's because the rest of our studies are more or less going to refer always back to this. So it gives us an idea of where the population is located in Ottawa. We did not study Gatineau, but for this purpose of the rest of our study, this is how we're going to be baselining our research. So is there a relationship between travel behavior and spectrum usage? And we believe the answer is yes. So I'm going to start with this first example, where what we're going to show you guys is basically that the LTE extends the internet's reach. And the current map that you're seeing right now, it's a heat map, but not of the OC Transpo. We only kept the routes of the OC Transpo, but the current heat map right now is the Wi-Fi download speed tests that were done by OpenSignal users. Now look carefully at this heat map, as it will expand once I want to overlay on top of it the LTE speed tests that were done by these OpenSignal users. Here we go. So did you notice a bit of a difference? You must have seen that there has been a bit of expansion. I'll go back once, and here we go again. So there are areas of the map now being covered with this heat map. So if we go back to our scenarios, which one would fit best to describe what we just saw? We believe it's scenario number 2, complementary. Basically that the travel demand leading to an increase in communications. People are using the internet outside of their homes, outside of their businesses. They're using it on the road, everywhere. So this is why we believe that complementary is the actual scenario we just observed. So let's take the question again, but let's see a second example. And in here, we believe that people are mobile, and this time around, the heat map of the OC Transpo bus routes, so basically where the population is well served by OC Transpo. And what you see on top of it are lines, basically the movement of people. When they were doing open signal speed tests, they were doing them not only from one location, but they actually do move as time passed by. And this is a window of 3 months worth of data set. And you notice that the lines are not short, some of them are quite long. So people are mobile by a good factor. So the next portion of the question, the big question that we had at the beginning of our presentation was, can we develop a big data analytical workflow? That was the first portion of that question. And we believe it's absolutely yes. So in here we have an example where we used the FME workbench to develop a workflow that helped us to group the bus stops in clusters based on their proximity. And the end result is what you see here. So we can do big data analytical workflows, and what you see here is the base map of Ottawa, and then on top of it is the clusters identified by the colors that you see. And they kind of resemble the real urban areas of Ottawa. You can see from the west end Canada, and then Nepean. At the bottom part is Barrhaven, and then you're getting closer to downtown Ottawa, and then Vanier and Orleans. So, if we go back to our big question, so can we develop a big data analytical workflow to predict the relationship between? I need to rephrase this. So we have our big question again. So can we develop a big data analytical workflow to predict the relationship between travel behavior and spectrum usage? And we believe yes. And you can do it while having a bit of fun. So I want to thank you for being here, and I want to especially thank my team. We were the smallest team, but we were, I think, one of the most efficient teams here. And I can't wait to hear what the other teams have also discovered. Thank you.